So we are at University of Surrey, and we have FARO Technologies for a demonstration with FARO Freestyle2, the newest laser scanner for hand. And our project is autonomous decision support system. So please, guys, talk about your new laser.
So yeah, this is the Freestyle2. It's made quite a leap from, if anybody's ever seen it before, the Freestyle1. The main thing that's been improved is actually the tracking. There's a lot of people have difficulties with the Freestyle1. The concept was there, but the device wasn't. So how this works then, it's different to your terrestrial laser scanners. If you've seen anything like the Focus, which is our main device, this is actually using structured light in order to create a point cloud live. So what that means then, there'll be one camera here. It sends out a like frame of dots that are invisible to the naked eye, and then there are two other cameras that are going to read those dots, and that's how it's building a point cloud as it goes. There's a constant camera then in the middle that is taking color photography, and it is then applying that color information to the point cloud as it builds. Now, the reason why it can create like a three-dimensional object then, why it can create a point cloud as it goes, is because it's using something called SLAM registration. What this means then is every frame as you go, it's taking a frame of points, it's registering that frame to the past certain number of frames. The exact algorithm, I won't be able to tell you. So as you go through the scene then, providing you have a constant overlap and a consistent overlap of unique geometry, it will register as it goes. And you'll see that on the screen yourselves when we get going in a minute. So the device itself then, as essentially a PC. This is a computer. It's got everything in that it needs to run as a computer. If you really wanted to, you could plug a HDMI cable into it and run it onto a monitor. A battery on top. This is the same as our batteries we use in our focus scanners. So if you do have focus scanners available, you could essentially use the same batteries. But yeah, other than that, there's not really too much to it. Charging dock on the bottom, so you could potentially use it whilst it's plugged in. And also on the bottom, a couple of USB ports and that HDMI cable I mentioned. The only other real reason to use the HDMI then is if you wanted to access the software that's on the device. There is software consistently running. This is where all the power is. Or if you wanted to do updates, see the Wi-Fi settings, anything like that, you can access it if you need. Other than that, the only real thing you're going to be needing is the USB ports. So these USB ports, at the end of all your scanning, just simply put a relatively large USB on there. You can bring all your projects over and then put them straight into our software, which is Scene. Into this then, you can see the cable plugged in at the top is the actual scanner itself. So the reason it's been separated then from the power to the scanner is to help with weight. With the old Freestyle, everything was in the handheld device itself. So it meant it was quite hard to use. It started getting a bit heavy, and once you start scanning a certain amount, your arm starts to ache. Also, you had to have a tablet running with the software on it. So because they've been separated now, this weighs approximately 3 pounds, and so does this. So it's actually quite manageable. Also, with smartphones getting better and better, we don't need a tablet anymore that you have to hold in one hand. It meant you had both hands occupied. With this now, you can keep this strapped to your waist somewhere, or belt, backpack, anything like that. And we can use a smartphone to control it. Because we're using a smartphone then, it can just stick on the top. This is done, put on with a magnet. It's got a magnet on the back of the phone itself. And then I've plugged it in with a little USB cable. Now, you can have a USB cable or you can have the Wi-Fi on. Either way, the phone is connected to this device. But all it's doing is acting as a screen display, nothing more. It's a control panel and a screen display. No data will be saved on the phone. All the data will be stored on the PC.
Okay. So the scans that are done in real time. That's comparing with the terrestrial scanner.
Yes.
When you have to do the scan and then to register them in computer.
That's it.
So now you see exactly what you do in real time.
It's almost like a preview process.
Yes.
The data will still need processing, okay?
Yes.
But you can do it on the device. But you can still view it before
You
processing
can acknowledge
because of the way
what
it
you
feels.
did. As
Yes,
well.
you can see it as you go. On that though, understanding registration, understanding how SLAM registration works does help, because there's no real way you could globally register all the frames together. So sometimes, for example, if you used to go around a particularly large object, that frame registration is consistent, but it's only registering to its previous frame. There's no way it can possibly register frames that haven't been recorded yet. So sometimes that stack in frames of deviation could lead to ghosting. So when you come back around to the starting point, sometimes you start to see a second set of everything where that registration has slowly gone out. But once you process things and put them into the software, then you do that's when you do a real global registration of those frames. And that ghosting starts to close up and you can start solving problems then. But that's a sort of problem with SLAM registration, and that's across the board. It's not just, you know, this device, because you cannot register to frames that don't exist yet. Okay, so with the device on then, my screen is now connected. All that's left to do is go into projects. You can see I've got a few on here already. We can add a project to start a new project.
Is it worth showing that process, sorry,
see that
on the camera?
I don't know what.
Yeah.
So let me know if they can see okay.
So in terms of captured speed, I think it does 220,000 points a second.
Yeah.
Okay,
so
great.
it
I
can
can
capture a
see.
huge
Yeah,
amount of data
yeah.
very quickly.
Yeah,
In terms of accuracy, I think it's 0.5 millimeter at 1 meter.
Yes.
What's the minimum distance you have to scan through the object?
So you can adjust that. You shouldn't go like any closer than 30 to 40 centimeters.
Mm-hmm.
But the distance that you can scan far away, you can increase it right up to 10, 15 meters. The problem is that that accuracy is going to grow. The deviation. Yeah.
The distance.
Mm-hmm.
So you can minimize the distance. At the moment, I've got this set to 5 meters. So any data that's past 5 meters, it won't even try and record. That's just to help reduce
From your
that
experience,
accuracy.
then what's the ideal distance to scan an object?
Around a meter. If you come away too far, you do get better registration sometimes because you can see more geometry. However, if you go too close, you do lose that registration. It's a tough one. It does depend on what you're scanning. It takes a bit of practice. You've just got to be careful of consistent geometry. Again, because of SLAM registration, if you suddenly have consistent geometry, it will lose tracking. If I just went up to the wall and found a plain surface, there's no possible way the device could know where it is on that wall, if you're moving or not. So you have to be aware of consistent geometry and adjust your range accordingly. So pretty easy then, add a project down on the bottom right, press add project, and we can just give this a quick name. I will call it University. Fortunately, because it's a touch screen on a phone, it's very easy to use. I may have already made one. I'll call this University 1. I'll just call it Quick Project 1 actually, a bit easier. It will then prepare the project. Then all that is left to do is press play. Big blue button here. We've got a couple of extra buttons actually on the device. One is start and stop scan. One adds the flash and removes the flash. From my experience and experimenting with it a bit, I recommend keeping the flash on. Because of the way this works with structured light, having that additional flash is helping pick up extra points. The other button then at the moment is kind of an experimentation button. This is a prototype unit. It does something called creating anchor points. Anchor points will help with the global registration of all of these frames. The more anchor points you put down, the more global registration points you can create.
So has a GPS incorporated?
Sorry?
Has a GPS incorporated?
No.
No.
Not at the moment.
with the flash, is that more helpful with shiny objects? Because I know that's a problem when you start.
It actually does help, yeah.
Does help.
It's
Okay.
just, especially so I'm doing a lot of cars at the moment. My background's in forensics. A lot of people are interested in this for crash scenes and scanning cars, because cars are hard to scan.
Yes.
All the time. And it does really well. It picks up the surfaces really well.
Yeah.
Now, Chrome is a different story. So
Yes,
that little thing there, it could be quite difficult. But yeah, you'll see if more scans you see, more point clouds you see. Actually, this is really good at picking up some difficult surfaces. All it has to do then is press play. And what I'm going to do is actually start by scanning the calibration plate. The reason I do this is because if I start here and finish here, it gives my scan a good start and finish point, so it loops. So those frames loop and I get a better global registration.
Can we move this one there? Because
Yeah,
I
yeah,
don't think it's,
Oh, sure.
Yeah, you move it wherever you need.
You can also use when you were talking about targeting the targets earlier. If you've got a larger space that you want to add targets to, you can print off individual ones of those. So they are unique. So as the device moves around, it will continue to track using those points. So just another point if you're doing an environment as opposed to a table top.
Okay, so what I'm going to do now is press play. And it will begin to capture. You see it flashing. And if you can see the screen, if you want to take a look, you can see it start to build the point cloud as you go. So I'll stay in this sort of area so you can come around and have a look. And you can see it's quite surreal seeing a point cloud build on the screen live as you go. And the thing that's really kind of interesting about it is how actually you can be quite ruthless with it. You don't have to be too slow and steady like you did with the old Freestyle. The old Freestyle had a real problem. They would have lost tracking a few times by now. But actually this one, I can be quite fast. If it does lose tracking, or if my geometry is getting too consistent or I'm moving too fast, it will start to warn me. There's a little haptic feedback, it will vibrate and something appears on the screen saying, hold on, slow down a little bit. So what I'm going to do is I'm going to try and get some of your more difficult objects here. And I'll just walk around the
small
table.
satellite, cube satellite. The pride and joy of university.
Want me to try and scan this? What I have to do is just walk around the other side of the table in a second, get the other side. At any time there's any problems, you've moved too fast or you've messed it up or everything's moving, you can just stop scan, same button, and press start again, start another whole new scan.
It may get confused now because I pulled the table away.
Yes, I know. If you move the objects while you're scanning, it might give you an error.
Well, that's it, especially when you're using SLAM registration. It's for common objects, but
It's done okay.
no, it's done fine. It's using this table.
For benefit of the video, it's still picking up data. So.
No, I think that's come out okay. What I'd do is, I would recommend not making scans too big, too long. There's a lot of frames, a lot of information there. And the last thing you want to do is spend 5 minutes scanning and have something to go wrong. So do relatively short, simple scans. The whole idea of this product initially was to be a gap filler for things like focus scanner. So when there's difficult to reach areas, mainly for public safety, market, where there's difficult areas, places that are hard to get to, you can use this instead of trying to get a scanner in there. However, because of its ease of use, people are seeing more and more potential for it.
I have a question. How can both scanners collaborate? How you can mix the both
what we can
scans?
do is this little...
no, I mean this one,
yes.
side with the terrestrial one.
Yeah, what you need to do is use markers.
Yes.
So you put down a couple of these markers. This is a principal marker. It's unique. Every one of them's different. So actually, when these are read in the software, they each have a number, and we have pages and pages of these. What you do is print off these markers, place them in the scene, in the area, providing the focus scanner and the freestyle scanner can both read those markers.
you can use them as a
Because
registration.
you might
point.
have a situation when you want to scan a big room and you want to have a very precision on a small object inside the room. So in my idea, I don't know, just tell me if it's right, you can scan the room with the terrestrial laser and then come with the small one and scan only the object.
Exactly.
So you have to put markers in the room.
Yes.
For terrestrial also?
For both of them.
For
yeah.
both.
They're
So
both
they will
inclusive.
have marks. They will
Yeah.
recognize these marks
Yeah.
and you can merge then
Yeah.
the
So
file.
neither need the markers, but if you
Yeah.
want to put the higher accuracy data with the lower accuracy data, or the terrestrial scan, maybe not lower accuracy, but if you want to combine the two, then they both have to see the same target to reference.
Yes,
Is that
right.
so?
Yeah, makes
that's
sense.
kind of the way you align.
To
But
have
you
a
don't need the
reference
markers.
point.
Yeah.
If you scan this room with a terrestrial, a few markers on this table would be fine. And then obviously you can scan the whole room, pick out the markers using the terrestrial laser scanner, then also pick out the markers on here. Both scans will recognize those markers as anchor points effectively, and then you can just overlay the two up together so you get the high
That's very
resolution.
interesting for our project also because we want to scan ISS,
Yeah.
the mockup, and you need all small cables inside. So we might need to come back with the hand laser and to pick up the small objects and to have a reference point then to merge.
I've got an example on my laptop. Unfortunately, it is public safety based. However, it's not real. It's just a demo. But it does show an example of focus scans merged with freestyle data, and the freestyle data was used for the more difficult intricate parts of the project. Anyone like to have a go? Have a go with it?
So
I'll let you start a new scan. What I'll do is I'll take this off, I'll walk around with it if you want. You can get an idea of it. So all you need to do is the best thing to do when it is saved.
I
just
have
at
to
the
start
page.
with
Yeah, I mean it's not an essential thing to do. It's just having best practice at the moment. So you need to do now, press the little play button in the middle.
just press the button.
Press the button.
Okay.
You'll start to see.
Shall I switch a bit more?
Yeah, just press it again. You need to tap it.
I think it likes me. Yeah, it's
Magic touch.
and how long shall I stay?
Well, so because the way it's working, it's recording so many points per frame, depending on what it can see. It will, so it's just telling you move a little bit quick there.
Okay.
That's okay, kept with you. So the longer you stay somewhere, the more that resolution
becomes
will fill
more.
in. Yeah.
Okay.
I have a question. Light, what's the wavelength?
Oh, I wouldn't be able to tell you off the top of my head.
Okay, all right.
I'll
But it's
certainly
coherent
find that
light,
out
it's
for you.
clearly not a laser.
No, no. So because of the way that is working and it's not a laser, it is affected by sunlight.
Yes,
Um,
and shiny things.
yeah, it records shiny things pretty well. It actually does a better job in dark environments. However, you may have issues in very direct light sunlight.
Be interested to scan the teapot again with the lights off.
Yeah, so give it a go.
Could you do me a favour? Could you lift the solar panel up so that you can, not sure, there's just a little bit of.
It will be.
Oh, it
will
will
get a bit
not pick
confused
it.
now.
It's
like-
confusing the
Yes,
laser.
yeah, I figured.
We
Yeah.
have to keep it.
Yeah.
open.
You'll end up with ghosting,
Yeah,
so like two
yeah.
versions of
Yeah.
everything.
Still picked up those walls over there actually.
Yeah.
It's interesting, it's confusing the autofocus on this,
Oh, really?
because this is infrared.
Oh, of course.
Yeah.
Ah.
I'm trying to figure out why it keeps, and that's the reason.
I think it's not.
Yeah. So when you're done, you just press the big play button again, and it will stop the scanner. So
Yeah. Okay, let's try to scan this one.
Okay.
Slide.
What I'll do is I'll bring the calibration plate over.
They're aware of, do they stay up or?
No,
No.
it's only
It doesn't
anyway, so if you just keep like that for the next half hour,
Okay.
that'll be fine.
I'll do.
That's it.
Dan, would it be possible to combine or delete the data from the previous scan and then combine this one again? I'm guessing probably
It could
not.
do, but you're going to have to do it like really controlled because I've seen this can pivot.
Yeah,
It's
it's really
rotate a
hard.
little bit.
Yeah.
You need it to be absolutely controlled, then pin them up. But then, yeah, you could delete the certain points out, certain method too. This again, just bring the calibration plate, get good data on it. And then I'll begin. What I'll do is I'll spend a little while on this and I'll try and give it the best chance possible to get quite good data in there. What the processing phase will do will filter out a lot of this noise you're seeing floating on it. It actually does quite a nice job of filtering out. Got that one.
Yeah, it's moving quite a bit actually.
Yeah, it's rotating, pivot on the spot, so.
This isn't going to be the best day.
But we get an idea. I think the important thing is seeing if you can read certain surfaces and get into certain gaps. You need to take that and I'll walk past.
Okay.
Yeah. There you go.
I knew I was useful for something.
When you're putting your report, so what did you do on that?
I just lifted a
And how the
solar panel.
solar panels, yeah.
Okay, I'll save that there.
Right,
Be interested to see
that's
how
right.
that one comes out. I look forward to seeing that one.
Okay, can we show on
Okay.
camera how it's looking?
Okay, that's what I'll do is I'll load up that last one. What I can even try and do, it may take a little while to have any problems, I could try and process one of them quickly.
Yeah, of course.
Um,
It's why we are here to see the
Of
whole
course.
process.
right, I will.
Can you go closer?
Okay.
How is the interface betwixt the phone and the scanner? Is it Bluetooth?
I know it's Wi-Fi at the moment, but you can have it by USB as well. So you should be able to see me. It's actually quite hard to see on there.
No, it's okay.
Can you see that? You know, I get
Yeah,
a
it's
bit
okay.
closer.
Yeah.
Now, it's a little bit noisy at the moment because there's a lot of moving parts to this, especially with us moving
Including
around.
us.
Yeah. But you can fully move around this. And I can also do this mesh visualization, which gives you a preview using the photographs. This is quite nice. So I'll just give it a minute to load. Is that focusing okay?
Yeah, it's not doing a too bad job.
Just give it
Quite
a minute.
overexposed.
Is it?
Not on the
Yeah.
on the camera, not on the phone.
Yeah, it's because of the light.
Yeah, it's okay.
Yeah, the background.
Just worth noting that's full 3D point cloud, so you can take measurements from that if you need to as well.
Okay.
So if you just wanted to know the length, width, height of the table, you can interrogate that in
What
software.
software do we use for this one? Because I know for terrestrial it's seen.
Mhm.
For this one, what software?
So
Seen
there's-
as well.
There's self-contained processing on the unit
Oh,
itself,
on
so
the
it will
computer.
process a point cloud for you. You can then put that data into Scene like you would use on the terrestrial and re-register the data to get a better result. So Scene that you've got on your PC is a bit more powerful and it works with the processing and registration a little bit better than that does. But as a quick, easy to use kind of device, it's point and click and away you go. Scene is a little bit more involved, as you may well know, so you have a bit more control over that final registration, and you can really tighten up the scans a lot more. So if you do see some of that overlaying, Scene will tighten that back up. I mean, it might not do it on the phone, but I think Scene has a bit more processing power to be able to look at that registration a bit better.
I'm not sure that we'll ever get to actually producing screens because we're not interested in the visual output. We're interested in that the resolution of the thin cloud, and then we will do the overlays with the augmented.
What is the main applications for you have for this device?
So wide and varied, to be honest. I think originally this device was used for forensics and public safety. So crime scene investigation, scanning, maybe weapons as well, and articles that are left at crime scenes. We're now moving it forward a little bit more into the building world. So as Tatiana mentioned before, terrestrial laser scanning is great, but where you need added resolution, or there's areas, so let's say you've got beams in the ceiling and you want to get on top of the beams, putting a laser scanner to get on top of an I-beam in a roof section is really difficult. Really easy with one of those. So you can then use that to pick up that full capture base of data. But to be honest, even visual effects and virtual reality companies are using these to digitize objects, props, people, cars. And there's a big move. Well, it's coming because you can't film crowd scenes. So digitizing people and things to put in scenes for movies, television programs, productions, that sort of thing is becoming a bit more important. So, you know, there's no real one perfect device. The device is really dependent on what you need from it. So, you know, a quick, easy to use point cloud. That's kind of,
if you want to use for the mobile robots for the scan, for the indoor mobile robot, I think it's fine. It does the job. But if you want to use for the outdoor robots, fast robots or small robots, do you think it does the job?
I think it's got the potential.
Yeah, just the amount of data. If you're using it on a robot outside, that could be autonomous for days, weeks, months. The data you're capturing could be huge. As long as you've got that, I guess,
it's a constant
scene to scene registration.
It would be a tough one because it depends on what you're doing outside. I mean, like, probably the externals of buildings and things, you'd probably be fine because there's so much constant geometry and things changing.
But at the moment you're capturing,
the road,
you're capturing data in here, so it's the capacity of that that's a limiting factor, right?
No, not just that. It's the style of registration. It's the SLAM registration. The fact that it's only registered into its previous frames. If you used to try and scan down a road, every frame is going to look the same, so it can't know where it is on the road. And it's the same thing when you do terrestrial scanning. If you use a terrestrial scanner, if you use to scan a road or a very large open area, you need to use targets and spheres because you need to have registration points.
Exactly what you said.
Otherwise, you could essentially have 2 free scans, but those scans could place anywhere on each other because the geometry is the same. So it's the same sort of problem. You have to have constant geometry. So items, objects, brilliant. Big outdoor spaces, you can have issues.
Good.
Go for it, David. See if you can break out, switch the lights off. Make it
It's fine. I saw when Tatiana. Thank you very much. Very good to
we want to see it. Right, there you go. Let's see it.
Let's see if I can get it. What I might do, I'm going to give myself every possible chance. See if I can get the surface.
Might get better than that. It does look better.
I'm doing a lot of my scanning at night, if I'm honest.
You don't have to wait too long for darkness on a spaceship. Comes around quite quickly after that.
Trouble is, no one can hear you scream. One of the things that we were looking at Sabre and I have worked on autonomous vehicles, so that's obviously something of interest, but we were even looking at the possibility of some sort of a droid, so that we could do the scanning with some sort of a mechanism. And, you know, we looked at some of the classic things, and, you know, it's inconceivable that you could use, you know, a classical hover drone type droid. But then we looked at different things that sort of move around. Because, as I say, I think one of the challenges is that we need to get different line of sight. And so we looked at several different mechanisms that we could use. And interestingly enough, we came up with a hexapod on the basis that it would give us the ability to move around and get the height. And of course, again, interestingly, on a spacecraft, it's not like a conventional thing that you could use wheels, because there's no ups and downs. But something like a hexapod.
So we've actually put our terrestrial scanner. So Boston Dynamics have a
Yeah, I know.
Yeah,
I've
sorry.
seen that.
The dog.
yeah,
The dog.
which is kind of cool. It will walk through upstairs,
What did they
downstairs, in
scan?
hazardous environments.
Yeah.
What did they scan with the dog?
They scan loads of things I can imagine.
Have you seen that dog, Sabre?
No.
Oh, it's quite neat. It's a Ford, but it's really very, very smart, and it's got some very what's the word? Lifelike movements. You can sort of kick it over, and the thing will go, "Oh, hang on, steady on." And all
Which
that.
one? The one from the Boston Dynamics?
Yeah.
Yeah, it's worth it.
And they put one of the terrestrial laser on top of it, so the dog can go around and scan.
Yeah.
But it's neat. It's neat. And it's cheap. Isn't it?
Yeah.
Of course I saw it.
Well, and
60k, isn't it?
Yeah.
60 or 70k.
then the laser thing is on top of that, isn't it?
Yeah, the laser system.
Yeah.
And UK is making similar dog. They call it animal,
Okay.
something like that. But they couldn't get the same performance as they did
Yeah.
in Boston Dynamics.
I mean, they've obviously been given huge amounts of USG money because it's truly quite amazing. You need to get them sober.
Yeah.
You got plenty of money left in the budget.
It's not disturbing for the laser when it's jumping.
So it will be when it's jumping. We can do mobile scanning. So this is actually on the automation adapter. So you can actually scan while it's moving, but obviously pitch your vibrations will affect capture.
Can we go on camera, please?
Yeah, that's very interesting.
Let me see if you can.
So
This is a pretty difficult object to do. It'd be interesting to see how the cleanup looks after once you process it properly.
Yeah.
This is just a quick process, but actually for a chrome surface,
It's pretty good.
it's pretty good.
Yeah.
I didn't know that.
Because if you, I'm not gonna lie, if you try to scan that with a terrestrial scanner,
Yeah.
you're not getting
Yeah, I know.
anything. You won't be getting that.
Oh, okay.
Is it not bad?
No, it's
No,
all
it's
right.
not. I have a Matterport and it's a nightmare.
Yeah.
If a light is coming in camera, you can't scan it
No.
at all.
No.
Doesn't align the scans, then you have to retake it.
And you can see there's a lot of obviously data reflecting off of it.
Yeah.
A lot of that would filter out when you process it properly, because basically it points out, it uses like a grid system, it just points out on their own. It must be a reflective bit of noise, so it cleans a lot of that out. So I'd actually hope that when I get it back later, I'll have another look at it. But I have a feeling that might come out quite nicely. Not bad of the surrounding objects as well as I was doing it.
I see you've already asked Tatiana, we're going to get some of these files.
Yes,
you to play
can
with.
we
Yeah.
have
Yeah, absolutely.
these
Yeah.
files to play with them and
just-
to give it to?
Do you have a preferred format? I
Well,
can export them
you
straight
can-
out as E57, so I can just give you the scene projects.
Well, we don't have seen. I don't know university having FARO, so and I don't have seen, as I told you.
Scene,
Seen it's the
Okay, so it's,
software from FARO Technologies.
So what I could do is I can give you maybe like E57 point clouds. Then maybe you can find viewers to check them out in there, because you're not going to have much freedom of being able to reprocess them or do much with them. But I can do.
But can be in same time translated in AutoCAD the file.
It depends what it is you're trying to do in AutoCAD.
To try to overlay on top of these wires, for example.
You should be able to import the E57 or PTS file or some XYZ. Should be able
What we
to
can do is
install.
I'll give you E57, see how you get on with them. If there's anything else, we can then come up with an idea, but we might have to do some work in scene. Yeah, I'm sure we can figure something out.
You
I'll
could even go
obviously keep
down.
everything. So
You could even go down, once you've done the work and seen the meshing in an STL mesher or something, so you can import an STL into scene, so, into AutoCAD, sorry. So that could work too. There's loads of different options, to be honest. It's all dependent on what you're doing with the data and also what platform and software you're using to work with that data in. There we go.
Okay, so that was our experiment for today with Professor and from university.
It was excellent to see the drawings, yeah?
Yeah, thank
Excellent.
you.
Okay, thank you, gentlemen.
You're more than welcome.
pleasure.